I'd like to introduce our next speaker. It's Buck Field, who has some fascinating things to talk about where we can go from these revolutionary advances and inspirations. He has an amazing background, everything from studying ideas with Mandelbrot himself to emergent perspectives to project management institute's guidelines for quantitative decision making. I mean, he's done it from A to Z in this kind of development, and I'm very pleased to introduce Buck.
Thank you.
Let me see if I can get the video playing. Might just miss the view.
All right.
Welcome to the Power of Synergy, October 23rd through 25th, 2018. The Tennessee Valley Interstellar Workshop is being held in Oak Ridge, Tennessee at the Y12 New Hope Center. Oak Ridge is one of 3 secret cities built in the United States for the Manhattan Project, which, in 1 decade, evolved theoretical ideas based on Einstein's famous equation to the most powerful atomic weapons of mass destruction the world had ever seen. Oak Ridge is proof of how planned transformations in human history can take place in 10 years. Recent creation of the Manhattan Project National Historic Park was celebrated with Japan's envoys to dedicate a huge friendship bell in Oak Ridge with its sister city Naka in Ibaraki, Japan, as a lasting symbol of peace. It is time to direct this potential for the benefit of humanity. To harness fission and fusion for peaceful purposes we celebrate in dreams of the future, like Star Trek. The Power of Synergy 2018 brings together intelligent, creative people who are passionate about our future in space. During this 3-day event, from October 23rd to the 25th, we will learn about knowledge areas from thought leaders at NASA, Department of Energy, Advanced Research Projects Agency, and national laboratories regarding topics often thought to be unrelated. When we have one idea and there's some other idea that seems completely unrelated, when we bring them together, we get a third idea. 1 + 1 = 3. And you get magic. Synergy is the term for 1 + 1 = 3. And that's what this event is all about. One of these synergies is the acceleration of space development from bringing together the capabilities of government and private industry. NASA and other public agencies will continue, but with an increasing role for private firms like SpaceX, Blue Origins, Bigelow, and Virgin Galactic. Theme 1 begins on October 23rd with Enabling Major Space Development. Attendees will engage in specific breakout teams they would like to collaborate with. The results flow on to affordable breakthroughs. These results flow to decadal plan development, and the event closes with how our envisioned science fiction futures relate to that plan's trajectory. This event is to advance human presence on the Moon, Mars, and Interstellar. It is your opportunity to discuss ideas and learn from space technology experts and contribute toward our inspiring future in space. Dr. Rather will present asteroid capture methods, David Brin on genetics and AI, and Dean Hartley on integration. Discussion across the 4 themes includes What It's Like to Live in Space by astronaut Franklin Ramon Chang Diaz and John Mankins details on moon opportunities. Theme 2 focuses on catalytic technology for breakthroughs on a budget, nuclear thermal rockets to Mars in 30 days. Jason Derleth explains NASA's Innovative Advanced Concepts Program basics and how they support major breakthroughs before 2030. It is impossible to do the speakers and their presentations justice, but here is a quick rundown of a few more. Join this amazing event and shape humanity's interstellar future by clicking the registration link below. Thanks so much for watching, and if you enjoyed this video, please click like, subscribe, and we hope to see you in beautiful Oak Ridge.
Thank you. I can see they're playing that off of YouTube. All right. faster than light synergies we're going to be talking about, and we'll use a clicker. The end. One of the most important things in rigorous planning is to begin with the end in mind. And although it's not suitable for marketing, one of the things that we look toward in our future is to getting into interstellar space. Because of the tremendous distances involved, that's not happening anytime soon. This presentation addresses the interstellar challenge through the lens of project management standards focused on successful delivery of strategic goals. These standards that you see here are the most widely vetted and used in the world. Our first step to success is to develop a vision of our ideal outcome. The classic Star Trek vision of success is the warp drive. Stargate's vision has wormholes, artificial. The film Contact did this as well. Deep Space Nine was sort of based on this. Battlestar Galactica had ships with jump technology or wormhole technology on board. There was the Star Wars hyperspace. Star Trek used transporters. In the real world, faster than light is not possible so far as we know. Why not? What is it exactly that prevents this? We can describe the increasing acceleration energies, but until we know what space and time are, we cannot know what possibilities exist for avoiding apparent constraints. Information like this, identifying exactly what we know, is something that we derive from following business analysis practices. Business analysis is concerned with getting requirements specific and precise based on studying the context and what it is we hope to achieve. This helps us build requirements appropriate for accomplishing success. Our information system environment is the standard model. This is where we're operating now. This is our context. It predicts the quantum mechanics and relativistic theories that we have predict measurements very well, but they don't explain in a way that we want from science. We want science to tell us more than simply that the sky is blue. We want it to explain to us why the sky is blue. Here's an answer to that. This is a cosmology from thousands of years ago. The waters above in this cosmology were separated from the waters below, and the dome of the sky that we see at night is a transparent crystal onto which stars were placed. This was this model, and the stories that went with it are beautiful, they're memorable, and they're easily communicated. It was highly tweetable. It matched the dominant religions of the time and the cosmogonies that they had. Okay, this flat Earth model, still somewhat around today. Living in this, there were unexplained anomalies that forced a change. This disk that we see was converted into a globe, and also layers, new spherical layers of crystals had to be added. Additional anomalies kept compounding, and the Earth-centered system had to be abandoned. Fast forward to today, and we have a century of unresolved conflicts between our quantum models of really small stuff and general relativity models on the large scale. Gravity is still largely mysterious, and we only have tentative guesses about why things are the way we see them and the way we do observe them. Quantum mechanics interpretations, which we see here on the right. This was a survey that was taken at a physics conference recently. What is your favorite interpretation of quantum mechanics? This this kind of survey, and on the left you can see someone was actually trying to make sense of different interpretations with a concept map. And this was somewhat likened to astrological charts or tarot card readings. Scientists tend not to like that comparison. Ruth brilliantly called this a disease. I thought that was quite accurate. No matter what they tried, nothing seemed to work. So, to resolve the problems, physicists eventually made some pretty desperate moves. Two popular ones emerged: supersymmetry, and that was contrasted in a battle with the multiverse. CERN was built and promoted primarily to settle this dispute. The question was the mass of the Higgs boson. That was going to settle which route was correct. 115 electron volts meant that our universe was supersymmetric. 140 meant the multiverse. There were thousands of person years invested. There were zillions of dollars. They turned on this most expensive machine in the history of our species, and disaster. The result was right in the middle at 125. So, Velociraptor has an opinion on this. If the multiverse theory is true, does that mean there's a universe where the multiverse theory is not true? It's funny, but it gets at a serious point, and that is falsifiability. This is the primary objection to the multiverse theory. We normally regard falsifiability and the ability to determine if our model is wrong as a critical feature of something to be taken seriously as science. When we're assessing the overall state, this has been done several times over the past 20 years. The duration and the intractability of research challenges comes up. The standard model assumptions need to be reviewed and reformulated. We get the Dark Energy Task Force here telling us that most experts believe nothing short of a revolution in our understanding of fundamental physics will be required to have a full understanding of cosmic acceleration. Here, this was a report that was largely centered out of Fermilab, and I had a minor role in this. The Quantum Universe Committee report said that the standard model's orderly and elegant view of the universe must be incorporated into a deeper theory. They were working on they were suggesting that this revolution was needed to explain 9 major mysteries in physics. 9. So, physics, with its problems, has synergy with deep space exploration. Both require revolution. Physics and engineering build the grand dreams. The duration and intractability of research challenges indicate standard model assumptions need to be reviewed and reformulated in order to hear and understand what nature is trying to tell us. In formal information systems analysis, we define assumptions as things taken to be true. Physicists sometimes talk about assumptions, but in risk management, these are bread and butter. Science generally, and physics in particular, are information systems, and this is an area in which I can contribute. To establish a revolutionary paradigm of the kind for which these blue ribbon panels are pleading, a transdisciplinary research effort is needed, and its life cycle looks like this. It will start, it'll be organized and prepared, the work will be carried out, they call that execution, along with monitoring and control of the execution to make sure it stays on track, and then we end the project. That's the model for planned successful change. One stated requirement was that this revolution would be as profound as any that have come before. While profound doesn't really tell us where to look, it's pretty vague. Shared commonalities of past revolutions and what made them profound can tell us where to look. This narrows our defined scope enough for us to apply rigorous project management discipline. The most important commonality of this type was identified years ago, it was about 10 years ago now, in the cognitive structure of scientific revolutions. Thomas Kuhn was mentioned earlier. His Structure of Scientific Revolutions, the most cited scientific work in the 20th century. There's a school of philosophers who have carried on in the Kuhnian tradition. And they identified in this book, and it had been hinted at earlier by other researchers, that a particular kind of recategorization was needed. And that was revealed as a commonality to cognitive changes in science that were particularly important, one might say profound. And at this point, I'm going to apologize because I'm going to have to perpetrate some philosophy upon you all. That special kind of cognitive change is when an object in one scientific paradigm is reformulated as a process. The blue sky is no longer a mere object. It is reformulated as a process of how we observe light scattering. The sun's movement is not a sphere object. It is reformulated as a process being viewed from the surface of a rotating Earth. The next standard model will recategorize a current object concept in a similar fashion. We don't know which of those are. It will probably be a couple. This is still pretty vague, but we've made some clarifying progress. And I use in project management, we call this progressive elaboration. And when I teach this, I use the fog analogy. Near-term things can be planned precisely, like our need for better math and physics, whereas very long-term situations, like faster than light, cannot be planned in any detail now. So, using these analytical tools and guidelines, we can tell there will be a reformulation, and we can tell it will apply to fundamental object concept in our current standard paradigm. Realizing this helps us focus our attention productively, and our resources as well. Because this is physics, we know the reformulation will, at some point, be expressed in math, geometry, and topology. To best improve our chances of success, we want to use the most rigorous mathematical approaches available. And if you talk to subject matter experts in that, you will very quickly hear about octonions, a type of Clifford algebra. Another discipline that appears likely to contribute is fractional geometry, or fractals, since that best mimics our observations. We have never observed a Euclidean line, a square, or a plane. We approximate things that way because it's convenient for the kind of creatures we are and the kind of math we have. We're used to counting because we have these. But in the real world, things don't work that way. Our fingers are not the same size. Only by abstracting away do we get that. Our symposium leader, John Rather, has made some striking proposals with topological models, and we got to review some of those at lunch. And these parallel other leaders in this area. Leading mathematicians have proposed this, and they should be developed in a program capable of leveraging their potential through rigorous, transdisciplinary, synergistic efforts. Good coordinated management of the disparate elements is needed to ensure the right tasks and resources are allocated to the right people. In PMI standards, the most common resource for planning any activity is expert judgment. If you look at Section 2, Tools and Techniques for each of these major process areas, number one, expert judgment is the thing that you want to do. And good project managers are skilled. They really have to be skilled if they're working on something substantially new. They have to be skilled at identifying the right experts. Absent that, advice is often taken seriously that is outside of one's field, such as Neil deGrasse Tyson. He's a supernova expert, but a bit off regarding human history. For risk management, we need to remember SMEs, subject matter experts, are experts in their field or skill, but not typically on management of their field or other skills or other fields. When NASA had to decide whether to crack open the gravity probe B at great risk and cost, as we see on the left, they applied risk management decision theory, which saved the mission. In contrast, DARPA funded an interstellar goal of the kind Philip emphasized, and DARPA chose not to include experts on sustainable organizational design or management. The graphic on the right illustrates the quality of that decision, and you can see it's wrong on so many levels. Okay, I apologize again. Take a look at this for a moment. Okay, if you can't read it, it has someone walking up to a lever and pulling it. They get zapped with an electric blast. Their steaming skull sits and stares at the lever for a moment, and then there's a switch. The normal person says, I guess I shouldn't do that. The scientist reaches back for the lever and says, I wonder if that happens every time. Now, it's funny, but it gets at a serious point, and that is our pragmatic concerns and our idealistic aspirations. This is William Bergerot's most famous painting that represents the problem. The seductive siren song beckons to us from our imagined future of, over here, of revolutionary paradigms, interstellar flight, whatever that dream is, whatever we're after, that's what we see. And the seductive siren song beckons us from our imagined future. It is whatever we desire. The nymphs represent our emotions. They pull us directly forward into a swamp of risk, mistakes, pseudoscience. That paradise could be an illusion. We don't know. Advanced planning, intellectual modesty and conservatism, and good, rigorous risk management are what will keep us on solid ground. And unfortunately, because of the screen ratio, I had to cut this off. There is the satyr's hoofs digging into the side of the bank next to the swamp there, and you can see that he's resisting, but you can tell it's almost a lost battle. The best practice recommendation for revolutionary physics is an independent, highly transdisciplinary project to lay the foundations for faster-than-light capability. A plausible first step would be partnering with universities and industry partners to provide math scholarships guided by these management best practices. It will be important to, as much as possible, prevent math researchers from building in current assumptions, some of which we know are flawed, from building those into their models. One risk in all of this is the possibility that we simply do not have brains that are smart enough or for whatever reason capable to model and visualize these things successfully. So, is that the end of the road? Well, that's a risk we've identified, and we can leverage that as well. Regardless of whether we're whether we're smart enough, artificial intelligence is probably an optimal tool to utilize. We will train, in such a project, we'll train learning AIs to generate physics models that are falsifiable, testable, and hopefully something that we can simplify for general communication and understanding. These simple models that we have, for example, of the scientific method, or where you have an angel on one shoulder or a devil on the other, these are toy models of psychology and battling with what kind of evaluation we should make for a good decision. It's a toy model, and it's good for communicating and use as long as we don't take it too seriously. Strong synergies for communications exist. That's what these visions are good for. Communicating the inspiration. Funders, policymakers, the public, everyone knows Star Trek. Want to justify the cost of math and physics portfolio to a skeptical politician? Point to a picture of the Enterprise and say, we're working toward that. This experiment of this obscure particle is to help us figure out that. The most obvious application areas for the U.S. to demonstrate leadership through such a project include aerospace, energy, defense, and transportation. One of the best advantages of this approach is its cost benefit. At less than $1 million a year, we could have new viable mathematical models in 3 to 4 years in a best case. And in an absolute worst case, we would have established new transdisciplinary links, organizational partnerships, public-private partnerships, management resources, and created dozens of the most advanced young mathematicians and theories in the world. Good management and best practices enable optimal resource allocation and the best possible decisions, but they are no guarantees of success. The world gets a say. The greatest benefit from a revolutionary new model will ultimately be like the past revolutions, beyond what we can currently imagine. Thank you.